There's a reason why I have you like standing up and doing it yourself, because it'll be boring to still listen to a bunch of definitions. One-to-one. It's also called injective functions. It's injective, or also known as one-to-one. If we're going to explore that definition in a second. So this is the definition of one-to-one. Alex seems to have had that teacher. How do you tell if a function's one-to-one when you were in, did you learn it in 7th grade, 8th grade? You learn it earlier and earlier now these days. One-to-one? Do you remember like a similar test where you had a bunch of things and you had to show that they were one-to-one or not one-to-one? If that one's called the vertical line test, what was the other one called? Horizontal line test. You kind of remember this? You might have had that in calculus, because I don't think they actually show anything about one-to-one functions, maybe pre-calc. They don't really show any one-to-one functions until you get to calculus, and they talk about one-to-one functions there because of the inverse function theorem. I don't know what the kid version of the inverse function theorem, but that's the function around implicit differentiation. They show it to you there. That's when you have a function and you can't solve for it in terms of y, the y is buried in there, and then there's a theorem, which no one cares about, that says that if I have a local area around it, I can invert it, and therefore I should be allowed to take that derivative implicitly. This is why my kids don't come to me for help in math, because I tell them all these things. Oh, you're using the inverse function theorem. TMI. Okay, another definition, one more. Also known as surjective. I have set. This is the hardest one to understand. This one's harder to understand. You did get onto functions in pre-calc for sure. They talked to you about x squared not being onto, because you have negative numbers that don't have an x that it can come from. There's no y. So if you drew y equals x squared, the whole bottom half of the graph is not there, right? The usual parabola, which is the only function they talk about in calculus, that function doesn't have anything on the underneath the stairs, right? It just is only a positive, non-negative, right? You draw that thing. So it's not onto, because if I took a y that was negative, it wouldn't have an x that led to f of x equals y. -1 has no x such that x squared is equal to y. right? So that's how that works. I don't, I think of everything in terms of tasks. I'm very task oriented. So when I look at onto, I'm thinking, prove something's onto, that's work. Because when their words there exist is in a proof, that means you actually have to produce it. Say, there it is, here's my X. And those kind of proofs are a little bit harder than other things. So I kind of map out my time accordingly, knowing that I have to show something exists. Okay, so you have two exercises.